So here I am in an RStudio and I want to tell you a little bit about boxplots. This script is 414 F15 5 boxplots, so if you want to follow along, that's the script I'm looking at. So suppose we have a set of durations. I'm going to call this variable dir1 and assign to it a list of numbers, which we can imagine are a list of different durations. And we're going to run from 200 to 475 in increments of 25. So I can say Command Enter, or if you're on a PC, Control Enter to run that line. And then you can see now we've assigned the variable to dir1, as you can see in the console down here, and it appears up here in the values. Um, if you're interested, another way to do this in R is to use a seek command. You can read about that in the help, but it does the exact same thing. Um, so now if I want to know the total number of observations in this list, I can say, let's find out what is the length of dir1. So if I run that in the console, it tells me it has length 12, so there's 12 durations here. And now I want to show you what happens when I make a box plot. There's different ways to make box plots in R. This is probably the simplest way. We'll do it a different way in class. But for now, one way to do is to just type in box plot, and then you can see here I've typed the where the data is coming from that I'm plotting. And then let me just go ahead and run this. And you can see that main equals boxplot of durations. That's a title. It appears here in the plots window. And then ylab duration milliseconds, that's a y label here, y-axis label. And here's our box plot. So I want to explain a few different quantities that are used in order to calculate the various parts of this box plot. And then we'll go through and I'll show you the different parts of this box plot. So in order to understand how those different parts of the box plot are calculated, we need to know something about quantiles. So remember we talked about what a median is. So if we take the median of dir1, it's going to be 337.5. Why is that? Well, if we go back to dir1 and we go through 1, 2, 3, 4, 5, 6, remember we have an even number, 12 observations here, so we actually have to, there's no middle number in this sequence of numbers, but we can take the average between the 6th and 7th number here, and that's where we get 337.5 down here, as we see in the console. Now, if I run this quantile command on dir1 in R, let me run that, you'll see in the console what appears is 0, 25%, 50%, 75%, 100%, and various numbers. So this is telling me something about the distribution of the numbers in these durations. So let's start off by noticing that the 50% here is exactly the median. So another word or term for the median is second quartile, or at 50%. And the way to understand that, as we've already said, is if you line up the durations from least to greatest, then you'll see if I divide that in half, I get length of dir1 divided by 2, that's 6. So if I'm halfway through those durations from smallest to biggest, then I am at the 50% point, as you can see when I get the third element in the list I get from quantile of dir1. And as we have been saying, the halfway point is between the 6th and 7th elements of the duration. So that's between 325 and 350. So that perfectly showed us why we would expect we get 337.5. The same kind of logic holds for calculating the first quartile. So quart, remember, that's this root for having to do with 4, right? Like quarter. And so the first quartile, that's like when we get through 25% of the data, going from the least to the biggest duration. So to understand that, now instead of going up to the 6th element, if we divide the length of dir1 by 4, that's 3, and so we want to go up between the values of the third and fourth elements in dir1 in order to get the quartile, first quartile 25%, which is 268.75. And we can see if we check, if we have our ordered list of durations, third and fourth elements, 250, 275, and indeed that's what we'd expect. We're going a quarter of the way through the list of durations from smallest to greatest, so that's how we get this first quartile. And same deal for the third quartile, except this time we're going 75% of the way through the list. And if we look at that, that's going up to the 9th element and beyond in the list. And so if we look again at what Quantile tells us, the fourth element of Quantile tells us that 75% of the way through in the list is 406.25. And indeed, remember we're looking at the 9th element and above in that list of ordered durations from least to biggest. And indeed, this calculated 75% of the way through is right between the 9th and the 10th elements in that list of durations. So that's how we get these calculations for the second quartile, which is just a median, the first quartile, and the third quartile. And the last thing we need to know is this term called the interquartile range. So this interquartile range. So what is that? First, I'm going to take the output from quantile dir1. Remember, quantile dir1 is just this guy telling us 0, 25%, 50%, so forth, all the way to 100%. Just to get rid of those headers of percents at the top, I'm going to change the data type to as.numeric. If you want to find out more about that, just check it out in help. But anyway, I wanted to find the interquartile range, or IQR, as the distance between the third and first quartiles. So third, remember, that's 75%. First, remember, that's 25%. So IQR is just going to be the quantor fourth element of quantor minus the second element, because that's the 75% minus the 25%. So you can see that if I calculate that, the values here tells me IQR is 137.5. And finally, for box plots, it will be important to have 1.5 times that, as I'll show you in a minute. So now let's pan quickly over to look at some box plots. So I just spent all this time telling you about all these quartiles and medians. Why? Well, because the box plot here, that line in the middle is exactly quartile 2, or Q2, which is the median. So 50% of the way through that list, or 337.50. Now then, this guy at the very bottom of the box is called the lower hinge, and that's exactly quartile 1, or 25% of the way through, which is 268.75. And then the upper line of the box is called the upper hinge, and that is exactly quartile 3, or 75% of the way through the data, and that's 406.25. So that's how you define the box. Again, we have the median in the middle, and then the lower hinge is quartile 1, and the upper hinge is quartile 3. Okay, and then what about the interquartile range? That's, remember, since the lower hinge is 25% and the upper hinge is 75%, the interquartile range is just the distance of the box. And so Q3, quartile 3, minus Q1, quartile 1, that's going to be 137.5, like we've seen as we calculated in R. And then so finally we have these what are called whiskers, the upper and lower whiskers. And the way we calculate what those are by using the interquartile range. So the upper whisker there, it extends upward to as far as 1.5 times the interquartile range above the upper hinge. And if you have a data point there, so if we do the calculation, Q3 plus 1.5 IQR, that's going to be 543.75. But you can see the upper whisker is actually at 475, and that's because the highest duration we have in our data set is 475. But if we had a duration that was as high as 543.75, then that upper whisker would go up to all the way to 543.75. All right, lower whisker, same deal. The lower whisker could extend as far below from the lower hinge as 1.5 times the interquartile range. So that could be as low as 62.5. But in our case, the lowest duration we have is actually 200. So the whisker will only extend as far as the lowest data point. If we had lower data points, it would extend further. So there we've got our box plot whiskers. The last thing I'll just mention is if you see points that occur beyond the whiskers, those are called outliers. And those are going to be, here we have an example where we have durations that are greater than Q3, that is quartile 3 or 75%, that is the upper hinge, plus 1.5 times IQR. So that's what outliers look like when you have a box plot. Stepping back to our studio, here's an example how I produce those outliers. So here's a second list of durations where I have some really low ones like 10 and some really high ones like 800 and 890. And if I do a box plot of that, you can see that's where our outliers are coming from, 800 and 890 right there. Those are the outliers because they're higher than what the upper whisker can be from 1.5 times the interquartile range above the upper hinge. So since they're outside that range, they become outliers. And you can notice that although we have a pretty long lower whisker here, we don't have any outliers because if you calculate the interquartile range, 10, our smallest duration, is still within the lower whisker at first quartile, or 25%, minus 1.5 times IQR. So there you have it. Box plots.